Okay, we're going to get a presentation now from Gavin Harte from Change.ie, and the Power of One, along with Dublin City Council, are offering a presentation called ClimateforChange, which aims to provide elected councillors an understanding of climate change and its implications for Dublin. Gavin Harte has a master's degree in sustainable development, and Gavin was the founder of the Clough-Jordan Eco-Village in County Tipperary. Great. So, Gavin.
Thank you very much, Mayor. Good evening, Mayor and members. Thank you for the invitation. It was at the behest of the Environment Committee that I was asked to return to give, I suppose, an awareness and education training that is available to local authorities throughout the country on behalf of Change and the Power of One, funded by the EPA and the Department of Community and Environment. There's a very important, I suppose, function for local authorities, particularly elected representatives, in your role as, I suppose, communicators and networkers, to understand the issue of climate change in a way that can assist you in decision-making and also to communicate this issue through the electorate in your area. I suppose the purpose of this talk is to try and give you an understanding of the science of climate change in hopefully an understandable and accessible way, and to assist you perhaps in decision-making that may come towards you from the Council with regards to issues that are relevant to climate change. So I'd like to just, from the point of view of the overall talk, to set the context of this, to give you a brief understanding of the science of climate change, and then to also present some of the impacts of this science, and then how, as a local authority, we may respond to this information in a way that can assist you. I think the first thing that we need to start off here is an understanding that we live in a very complex climatic system. We have a planetary climatic system, and this is often confused with weather and climate. And I'll touch on this later on, but here we see Ireland being influenced by one small part of a hugely complex climatic system that really science is struggling to understand in its infinity. We understand the big picture story, but the details of why it's wet or cold or dry, these are complex issues to calculate and model. But we do know the big story. And I suppose the big story has one key part in it that science is clearly understanding of now, and this is the impact of this molecule, carbon dioxide, and its part in this whole process of a changing climate. It is a complicated story. There are four basic parts to the climate change story. The first is that human activities are now changing the chemistry of our atmosphere. This changed chemistry is impacting on the climatic system, and this poses major threats to our economy, our society, and to the natural environment. The human activities end of this are really quite simple. We're doing two things. We're burning fossil fuels and we're changing land use. As a result of this, we're releasing a basket of greenhouse gases into the atmosphere, and this is changing the chemistry of our atmosphere. It's like changing the recipe of our atmosphere. This changed recipe is enhancing what is called the greenhouse effect, and I'll explain that to you in a minute. But this is altering our climate. We are seeing changes in precipitation, in cloud cover, in the salinity of our oceans, in a whole host of different climatic influences. And collectively, this poses major threats to our economy, to our society, and to the natural environment. So it is a complicated story and often difficult to grasp in its scale, but at its core there are two things going on: the burning of fossil fuels and the changing of land use, which are collectively releasing greenhouse gases into the atmosphere and enhancing the greenhouse effect. Who can we blame for all of this? Well, we can blame one man. If we go back to 1769, Mr. James Watt, when he invented his steam engine, because it's quite clear when we take a look at the release of greenhouse gases since the Industrial Revolution in 1750, that the concentration of greenhouse gases in our atmosphere has now increased by 30% since that time. This is directly linked to the burning of fossil fuels. Over the next two slides, I want to convince you of the science of climate change so that you understand exactly what's going on. And the first thing we need to understand here is the unique property of carbon dioxide and its ability to hold heat. A short scientific experiment will hopefully explain that unique quality to you.
I can show you how carbon dioxide affects the Earth's climate using this heat-sensitive or infrared camera which is purring away here, and a candle, this glass tube which is hooked up to this rather large canister of carbon dioxide gas. Now if I light the candle, you'll see that on the monitor the camera picks up the flame perfectly. Look at that, the hottest parts are glowing white. Now watch what happens when I turn on the carbon dioxide. Just keep your eye on the flame. The gas is invisible, so you don't see it fill in the tube, but as it comes in, you should see the candle start to disappear. There it goes. Look at that. What's happening is that the carbon dioxide in the tube is effectively trapping the heat. The candle's warmth no longer reaches the camera. Instead, it's absorbed by the carbon dioxide inside the tube.
So this is the unique quality of carbon dioxide. It has this ability to hold heat. And this is the reason, as we add more of this to the atmosphere, why our atmosphere is now warming. The second part of this science is essentially been measured in Hawaii since the 1950s. And this is scientific data where they have been continuously monitoring the concentration of CO2 in our atmosphere. Scientists have been measuring repeatedly how much CO2 is over those mountains in Hawaii. And there's two stories in this. The first is the story of our planet breathing. And this is what's called the carbon cycle. As growth comes on in the northern hemisphere in summer, spring and summer, a load of carbon dioxide is absorbed out of the atmosphere. And this is the dip that you see in this saw. And then when all those leaves rot and decay, carbon dioxide is released back out into the atmosphere. And this is like our planet breathing. This is the carbon cycle, and this is the very stuff of life. If this didn't happen, there would be no life on this planet. But the other hidden piece in this story is the black line. And this is the year-on-year increase in the concentration of CO2 in our atmosphere. And this is directly linked to human activity, the burning of fossil fuels and the changing of land use. To the point that, as I said earlier, we have increased it by over 30% in the period since James Watt fired up his steam engine. Another very important part of the climate change story is the understanding that we know the difference between weather and climate. These are two very different things, and we need to understand this distinction if we're going to understand climate change. Weather is short-term. Weather is measured in terms of days, whereas climate is long-term. We need to think of it in terms of years. Weather is whether it's hot, cold, wet, or dry. Climate is winter, spring, summer, autumn. It's the trends in weather. In fact, scientists measure climate as the trends in weather over a 30-year period. So what has been happening over a period of time, that's the distinction between weather and climate. And just to explain that from Dublin, from locals' from our point of view in this city, measured since the 1940s the number of hot days and cold days at Dublin Airport. And here we see the ups and downs of weather. We have a hot year, we have a cold year. But as we start to put an average across those figures, we start to see climate emerge. The trend. A 10-year trend and then a 30-year trend. To the point that since the 1940s, the east coast of Ireland has doubled the number of hot days and the number of cold days have halved. Now everyone says, well, what about this winter? And here again is often the paradox of climate change. You know, people said that where is the evidence of global warming when we had such a cold winter? But again, we need to think of this as global climate change. This is not in my backyard change. We must think of it globally. And again, we can see for the winter of 2009-2010, the parts of the world that were below average. They were cold for the winter of that time. And sure enough, Ireland, smack in there, we experienced an exceptionally cold winter. But it's not until we step back and look at the whole picture that we start to understand, in fact, that the winter of 2009-2010 was actually the second hottest winter on record. And this is often difficult for us to grasp when it comes to understanding climate change. Because here in Ireland we experienced an exceptionally cold winter, but globally it was the second warmest winter on record. In fact, 2010 is now statistically tied as the hottest year on record. And if we look at the trend over the last 150 years since 1850, we can see that what has happened over the last 16 years is that 15 of the warmest years on record have happened in the last 16 years, and that this trend is now accelerating. When we take a look at the overall period of a 100-year trend, a 150-year trend, and an acceleration in the speed. I'm saying this because the largest scientific experiment ever carried out by humanity, by the Intergovernmental Panel on Climate Change, is absolutely clear. There is no more doubt about the science. And this is clear that climate change is unequivocal. It is evident from observations in increasing in global average air and ocean temperature, widespread melting of snow and ice, and rising global average sea level. The top level messages from the IPCC meeting are stark. We're likely to see temperature increase of between 2 and 6 degrees, sea level rise of 1 to 2 meters over the next 100 years, continuing melting of snow and ice, increased tropical cyclones and hurricane strength, and very likely that hot extreme heat waves and heavy rainfall will become more frequent. A world 4 degrees hotter, some people think, well, that's no big deal. But in fact, 4 degrees averaged across the whole planet is an enormous temperature increase. Think of it like your own body temperature. A healthy human being has a healthy body temperature in and around 37 degrees centigrade. Our healthy planet's temperature before we started burning fossil fuels was about 13.5 degrees centigrade. If we proceed business as usual and carry through over the next 100 years to increase temperatures to between 2 and 6 degrees above normal, that is moving the planet into a very risky state. To come back to our body analogy, if you were to appear in hospital with a temperature 3.5 degrees above normal, you would be potentially critically fatal illness. That is how serious climate change is, and 4 degrees, while it sounds little, is significant as a global average. A second issue is sea level rise. People in Dublin may remember the shocking flooding event that happened in February 2001. It's important that we understand the significance of that event. That was a shocking event for the city of Dublin. And when we take a look at it, we can see that any engineer will tell you it was a once in 100-year flooding event. And this was an exceptional weather and gathering of events that caused a tidal surge up into the Irish Sea. If we add half a metre of sea level to that average, we see that instead of happening once every 100 years, parts of Dublin will be influenced by flooding every 10 years. Or if we add 1 metre of sea level, which is the low end of the IPCC scale, we're seeing parts of the city underwater all the time. A 2-metre rise across a city like Dublin, a port city like Dublin, has potentially huge significance. And we need to take these projections seriously. The question really is, can we change or do we not change? We need a climate for change. Because the climate is changing and we need to adapt accordingly. The worrying part of this is that with the global recession and with current preoccupation with market and economy, we're missing this big one. And yet we may be in 10 years' time saying we didn't see it coming, but we actually do see it coming. That is no longer an excuse to say that we didn't see this on the horizon. The worrying trend is that within public opinion, we're starting to see people, in other words, not buy the story of climate change, and increase in the number of people who actually say it is not occurring. And in measurements of media coverage across newspapers all over the world, again we're seeing a worrying trend in the uptake and communication of this story. In In a study in America and in Britain, where they're measuring the amount of media coverage on climate change, we are actually seeing that it appears to be like a fashion item. Appears with things like Al Gore's movie or the Copenhagen talks. But in fact, media coverage of climate change is now back to 2004 levels of coverage. As councillors, as communicators, as people who have a vital function in communicating important issues like this, it's important that you are aware of what the climate change story is about. Dublin City Council is taking a very leading role with its sustainability agenda, and I understand in November there's going to be a sustainability report by the city, and this is going to be part of an ongoing programme to measure your own carbon footprint and taking active consideration in this area. So again, hopefully this presentation has given you some understanding of the implications of climate change and your roles as councillors in this story. Thank you very much.